Hello, my name is Rishabh Sinha and today we will learn about the array in data structure. So this is one of the most important topics of data structure after pointer. So let's begin. So first of all we have to know that what is the introduction of arrays. So we will discuss the array in data structure. Arrays are defined as the collection of similar types of data items stored at contiguous memory locations. It is one of the simplest data structures where each data element can be randomly accessed by using its index number. In C programming, they are the derived data types that can store the primitive type of data such as integer, character, double, float, etc. For example, if we want to store the marks of a student in 6 subjects, then we don't need to define a different variable for the marks in different subjects. Instead, we can define an array that can store the marks in each subject at the contiguous memory locations. So, next is properties of array. Here are some of the properties of an array that are listed as follows. Each element in an array is one of the same data type and carries the same size, that is 4 bytes. Elements in the array are stored at contiguous memory locations, from which the first element is stored at the smallest memory location. The third point is elements of the array can be randomly accessed, since we can calculate the address of each element of the array with this given base address and the size of the data element. Then we will come to the representation of the array. So we can represent an array in various ways in different programming languages. As an illustration, we will see the declaration of array in C language. So from this diagram, we can say that first of all we know that index starts with 0. So here we can see the array's length is 10, which means we can store 10 elements. Each element in the array can be accessed via its index. So why are arrays required in data structure? Arrays are useful because sorting and searching a value in an array is easier. Arrays are based to process multiple values quickly and easily. Arrays are good for storing multiple values in a single variable. In computer programming, most cases require storing a large number of data of a similar type. To store such an amount of data, we need to define a large number of variables. It would be very difficult to remember the names of all the variables while writing the programs. Instead of naming all the variables with a different name, it is better to define an array and store all the elements into it. So second is the memory allocation of an array. So what do we mean by memory allocation? As we have seen earlier, that all the data elements of an array are sorted at contiguous locations in the main memory. The name of the array represents the base address or the address of the first element in the main memory. Each element of the array is represented by proper indexing. We can define the indexing of an array in the below ways. 0. Zero based indexing. The first element of the array will be array, which is 0. Then is 1. The first element of the array will be 1, and n means the number of element or the array can reside at any random index number. So in this diagram we will see that the arrows follow a 0 based indexing approach. The base address of the array is 100 bytes. It is the address of array, which means 0. Here you can see. So here the size of the data type used is 4 bytes. Therefore, each element will take 4 bytes of memory. So how to access an element from the array? So we require the information given below to access any random element from the array. The base address of the array, the size of an element in bytes, the type of indexing, array forms. The formula to calculate the address to access an array element is the byte address of an element a of I equals to base address plus size into I minus first index. This is the formula which we will require to calculate the address so that we can access an array element. But here the size represents the memory taken by the primitive data types. As an instance, the integer takes 2 bytes, float takes 4 bytes of memory space in C programming. So what are the basic operations? Now let's discuss the basic operations supported in the array. First is traversal. This operation is used to print the elements of the array. Insertion. It is used to add an element at a particular index. Next is deletion. It is used to delete an element. Then the search option. So this operation we perform so that it is used to search an element using the given index or by the value. And finally the update. It updates an element at a particular index. So what is traversal operation? If we can say that this operation is performed to traverse through the array elements, it prints all array elements one after another. Then the insertion. So what do we mean? That this operation is performed to insert one or more elements into an array. As per the requirements, an element can be added at the beginning, end or at the index of the array. Then is the deletion operation. So as the name implies, this operation removes an element from the array and then reorganizes all the array elements. Then is the search operation. This operation is performed to search an element in the array based on the value or index. Then is finally the update operation. This operation is performed to update an existing array element located at the given index. Now the complexity of array operations. So we always know that time and space complexity of various array operations are described. So we will now see the following table, that this is the operation which are performed, that is access, search, insertion, deletion, and their average case is O of 1, O of n and so on, and the worst case is also O of 1 and O n. This follows. So you guys have to remember this operation and their average and worst case, so that when you will do programming, this will be beneficial for you. So the space, this is the part of the time complexity, and coming to the space complexity, we can say that space complexity for worst case is O of n. Now the advantages of array. So we all know that there are some advantages and disadvantages will be obviously there. So at first we will learn about the advantages of array. Array provides the single name for the group of variables of the same type. Therefore, it is easy to remember the name of all the elements of an array. Traversing an array is a very simple process. We just need to increment the base address of the array in order to visit each element one by one. Any element in the array can be directly accessed by using the index. So what are the disadvantages of array? Array is homogeneous. It means that the elements with similar data type can be stored in it. In array, there is static memory allocation, that is, size of an array cannot be altered. There will be wastage of memory if we store less number of elements than the declared size. So what is we have learned about the array, and finally after learning the array, we can say that we have discussed the spatial data and structure, that is advantages, disadvantages, complexity, right? So the basic operations performed on it, we have seen about that matter. Now arrays, we can say that arrays provide a unique way to structure the stored data such that it can be easily accessed and can be queried to fetch the value using the index. So now coming to the 2D array. So what is 2D array? 2D array or two-dimensional array can be defined as an array of arrays. The 2D array is organized as matrices, which can be represented as the collection of rows and columns. However, 2D arrays are created to implement a relational database look-alike data structure. It provides ease of holding bulk of data at once, which can be passed to any number of functions wherever required. So how can we declare the 2D array? The syntax of declaring two-dimensional array is very much similar to that of a one-dimensional array, given as follows. Integer of array, max of underscore rows and max underscore columns. So these are 2D array. As we see that max rows and max columns are arrays which are, there are two arrays, right? So that means there are two-dimensional arrays. Now from this diagram we can say that this image shows the two-dimensional array. The elements are organized in the form of rows and columns. First element of the first row is represented by A00, right? Here I can say that A00. So this is the first row, the first element of the first row, where the number shown in the first index is the number of that row, while the number shown in the second index is the number of column, right? So hang on a second. Yes, this 0 represents this row and this 0 represents this column of row, right? Similarly, we can say that A of 0 represents this row and A of 1 represents this column. Again, coming to second or third, we can say that A of 3 represents the third row, right? And A of 0 represents the zeroth column. Similarly, A of 3 represents this third row and second is the second column. Similarly, we will see that n-1 up. We can say that A of n-1 and 0 represents this row and column. And similarly, A of n represents the number of arrays, the infinite number of rows and columns, right? So this n represents the number of rows, infinite number of rows, and this n represents the infinite number of columns, right? So how do we access data in a 2D array? Due to the fact that the elements of 2D arrays can be randomly accessed, similarly to one-dimensional arrays, we can access the individual cells in a 2D array by using the indices of the cells. There are two indices attached to a particular cell. One is its row number while the other is its column number. However, we can store the value stored in any particular cell of a 2D array to some variable x by using the following syntax. That is, integer of x equals to a of I and j, where I and j is the row and column number of the cell respectively. We can assign each cell of a 2D array to 0 by using the following code, this code, right? So for of integer I equals to 0, I less than n, I plus 1, which means that it will increment the rows by plus 1. Then again the j equals to 0, j less than n, j plus plus means it will increase the column by 1. So the mapping 2D array to ID array. So what do we mean by mapping 2D array to 1D array? So when it comes to a map, a two-dimensional array, most of us might think that why this mapping is required. However, 2D arrays exist from the upper point of view. 2D arrays are created to implement a relational database table look-alike data structure. In computer memory, the storage technique for 2D array is similar to that of a one-dimensional array. The size of a two-dimensional array is equal to the multiplication of number of rows and the number of columns present in the array. We do need to map two-dimensional arrays to the one-dimensional array in order to store them in the memory. Now, the two main techniques of storing 2D array elements into memory are the row measure ordering and the column measure ordering, right? So what do we mean by row measure ordering? In row measure ordering, all the rows of the 2D array are stored into the memory contiguously. And similarly, in column measure ordering, according to the column measure ordering, all the columns of 2D array are stored into the memory contiguously. Here, the rows of the 2D memory, all the rows of the 2D array are stored into the memory contiguously, and here all the columns of the 2D array are stored into the memory contiguously. So that's all from my side. So today we have learned about the full concept of array and 2D array. So in the next lecture we will see about the another important topic of data structure. Till then, bye bye.